Distance time question with trigonometry mixed in. So it wants me to show that the total length of the course is 62 kilometers and 62 kilometers. So let me see. Each must swim 4 kilometers from C to B. C to B is 4 kilometers. They must cycle from B to A. B to A is a cycle, so you're on a bike for this part. And then they run 28 kilometers from A to C. Now, Mary can cycle an average speed of 25 kilometers an hour and takes her 1 hour and 12 minutes to cycle from B to A. Distance equals speed multiplied by time. Speed is 25 kilometers an hour, and you can multiply it by 1 hour and 12 minutes using this button here. So 1 hour, 12 minutes multiplied by 25 gets you 30. So that means that this here is 30. And then when you add up all three sides together, 30 plus 28 plus 4, you're going to get a grand total of 62 kilometers. And we'd hope that everybody gets that question out. That'd be nice. Okay. You could also use 12 over 60 is a fifth of an hour, or 0.2. So somebody is could have multiplied by 1.2. 25 multiplied by 1.2 is also 30 kilometers. Whatever you want to do there. Now, on average, Mary can run 5.6 times faster than she can swim. It takes her 4.8 hours to complete the course. Find her average swimming speed. Okay. I'm going to actually need this diagram again. So I'm just going to draw it here myself. What do I have? A, B, C. And we know that this here is, we know that B to C is 4 kilometers. And we know that A to C is 28 kilometers. And we actually know the time for A to B. We know that that's 1 hour and 12 minutes. Okay. Now, 4.8 hours. 4.8 hours. 1 hour and 12 minutes. 1 hour shift. 1 hour and 12 out of 60 minutes is actually 1.2 hours. You can see it here. So I'll just change it to 1.2 hours. The reason being is it's given to me in decimals. So that's 1.2 hours. This means the combination of the running and the swimming results in 4.8 take away 1.2, which is 3.6. Now what we're going to do next is it takes 3.6 hours to finish the rest of the course. Now, time equals distance divided by speed. And what I'm going to say is let x be the swimming speed. So x is going to be the swimming speed, okay? So what we can say is that this 3.6 is divided up into two sections. It's divided up into swimming, which is going to be 4 kilometers divided by your speed x. And then it's also going to be divided up into the running, which is 28 kilometers. Now remember, your speed isn't x anymore because you can run 5.6 times as fast. So that's going to be 5.6x. And when you add all that together, it equals 3.6. Now, I'm inclined to get rid of the decimals and try and turn this into a fraction. So 28 divided by 5.6. Oh, turns out to be 5. That's great. That's 5 over x. That's 4 over x. And this in turn is going to be 3.6. I'll put that into fraction as well. That's going to be 18 over 5. So here's what I'm going to do. I'm going to give them all a common denominator. So common denominator is going to be 5x. Put an x there. Put a 5 here and a 5 here. Put a 5 on the bottom, 5 on top. And what I'm going to get is 20 plus 25 equals 18x. 45 equals 18x. And 45x equals 45 divided by 18. And 45 divided by 18 is going to be 2.5. X equals 2.5. So the swimming speed is 2.5 kilometers per hour. Now, what is it actually looking for me? Oh, wants her average swimming speed. That's great. So I figured that out. It's 2.5 kilometers an hour. Hooray. Next thing. Show that the angle ACB is 116.5. Okay. So what this might mean here is I'm going to just grab this diagram here. Oh, do not want to snip a sketch. Give me 1 second. I'm just going to grab this here. I'm just going to copy and paste it across. Here we go. Yeah, it's a bit on the large side, but I'll be able to tone that down in a second. Okay, so here's my diagram from part 1. And we see all the lengths. Okay, now it wants me to do ACB, C being the middle letter. So this is talking about this big blue angle here. It's already marked for you in the question. We're going to use the cosine rule. And the reason being is you don't use Pythagoras' theorem because it's not a right angle triangle. You don't use SOHCAHTOA or sine cos tan because it's not a right angle triangle. So this is not a right angle triangle, so you have a choice between the sine rule. And you can't use the sine rule because you're looking for, you need another angle. You need at least, there's 2 angles in this, so you at least need 1 angle to figure it out. So the sine rule is the wrong choice. This leaves over the cosine rule. Is the only choice you're going to be able to use for this question. Now, the angle we're going to use is this one here. So we're going to, for argument's sake, this is going to be angle A, and this makes small a 30. So we're going to have 30 squared equals 28 squared plus 4 squared minus 2 times 28 times 4 cos A. Now this is an angle question, so we're going to put a defensive barrier around this because they're linked by multiplication. And what we're going to do is we're going to do 30 squared, take away 28 squared, take away 4 squared. So it's going to be 30 squared minus 28 squared minus 4 squared, because we're going to bring them over to the other side eventually. And what we're going to get there is 100. 100 equals, now we're going to do this part here, it's going to be minus 2 times 28 times 4 minus 224 cos A. Now here's the next part. Cos A is going to be 100 divided by minus 224. Okay, so we're going to cos inverse that to find our angle. So shift cos inverse 100 divided by minus 224. This seems to be a nice little question. 116.5. And there we go. Happy days. Now, give me a second. I need to get something. Now, to comply with safety regions, the region inside the triangular course must be kept clear of people. If the area, find the area of this region. Alright, it's the area of a triangle. Okay, so that's a half AB sine C. It's the area of any, it's use any 2 sides and the angle in between. So we know, using our information from our last question, we have a 28, we have the number 4, and then we know that this angle in between is 116.5. So what we can just quite simply do there is just a half 28 times 4 sine 116.5. I'm going to just throw all that into the calculator and get our answer in. .28 times 4 sine 116.5, and we get 50.11, or 50.1 kilometers squared. Once again, I was checking my answers using the marking scheme on my phone, and 50.1 is the correct answer. Okay, so let's move on. Now, find the shortest distance from the point C to the side AB. Give your answer in kilometers. Correct to one decimal place. This is like the second year in a row they've been very keen on this type of question. So I'm going to drag this down from earlier. Just going to grab my picture from earlier and bring it down, and I'll show you the trick to keep using on us. And they've been very keen to use this half base by perpendicular height last two in 2021 and in 2022. So the point C to the side AB, the closest distance is perpendicular distance. Okay. Now, if you were to use the traditional half base times height, you're talking about a half 30, which is this blue line here, times h, which will be the yellow line. Okay, so essentially a half 30 times h is the same area that we got in the last question, 50.1, because it's the same triangle at the end of the day. So 15h equals 50.1, h equals 50.1 divided by 15, and we're going to go for that there. 50.1 divided by 15, and we're going to get 3.34. And to one decimal place, we're talking 3.3. Once again, verifying with the notes here, and yep, we've got that one right. It is in fact 3.3. Perfect. Now, part F. The course is viewed from a camera tower which rises vertically from the point A. Now, the thing is, the course is on flat ground, and this tower is directly up. Any triangles that have TA as a side will more than likely be right angled. Okay? So what does it want from me now? The angle of elevation from B. So we're talking about this angle here. We're talking about the triangle TAB. So that's TAB. I'm just drawing it in 2D over here. So T to A is right angled, and that is B. Okay. Now, do we know what A to B is lengthwise? I think we did from the last question. A to B is 30k. And the angle of elevation of T from B, so that is 0.05. And it'd like me to figure out X, the length of TA. It's quite a simple question, just a right angled triangle. So we can use Pythagoras or SOHCAHTOA. Now, because we haven't got two lengths, we're more than likely going to have to use SOHCAHTOA. I'm after the opposite, and I know the adjacent. That means I'm going to use tan. I'm going to use tan 0.05 equals x over 30. And then this x value is going to equal 30 tan 0.05. I'll load that into the calculator. And we're going to get 0.026 of a kilometer. Now, I'm going to reread the question, see if it wants it in kilometers or meters. It wants it in meters. So, I'm going to multiply this by 1,000. That's going to be 26.18. Or simply 26 meters. Once again, checking the marking scheme. And 26 meters it is. And that's that question done and dusted. It was actually a very easy question that year.